Imagine a vast assembly orchestrated by an infinite multitude of stars, planets, and moons, all performing together exquisitely. Nonetheless, there exists one distinct segment of this symphony that has astonished astronomers for an exceptionally extended period: exoplanets. Exoplanets are ordinary planets that reside beyond our solar system, concealed somewhere deep within the Milky Way. You may be amazed to learn that amid the immense quantity of celestial bodies, there are exoplanets so akin to Earth, so tantalizingly similar, yet enigmatic that they could be our planet's celestial counterpart. We dive into the fascinating domain of Proxima Centauri B, discovered just 4.2 light-years away. The James Webb Space Telescope, JWST, is disrupting our expedition toward understanding these cosmic enigmas, a cosmos of opportunities. Picture, for a moment, your mind traversing the vast astronomical expanse of our galaxy, the Milky Way, which contains more than a quadrillion exoplanets. That's a number with 15 zeros. To contextualize, if each exoplanet were as tiny as a grain of sand, we wouldn't just fill the Grand Canyon, we'd have enough to shape another terrestrial wonder, a Grand Canyon 2.0, stretching an enormous distance. Remarkably, about 20% of these colossal bodies are classified as Earth-like in terms of geography and atmospheric composition. That implies a 1 in 5 probability of discovering a twin to our world. And the narrative doesn't stop there. Orbiting these planets might be another quadrillion moons, satellites similar to our moon captured in gravitational dance with their host planets. If you ever yearn to seek another life-harboring object in space, or one capable of it, the universe provides a torrent of possibilities. The all-seeing James Webb Space Telescope. Now that we've laid out the grandeur of scale, it's time to introduce the virtuoso artist, ready to reveal its nuanced brilliance, the James Webb Space Telescope. This celestial detective, with its expanded primary mirror composed of segmented reflective surfaces, surpasses even the most sophisticated optical tools. Its 6.5-meter primary mirror is 2.7 times larger than Hubble's. Envision the finest detail it can resolve, from the tiniest flicker of a star billions of light-years away to the subtleties surrounding orbiting planets. What makes James Webb revolutionary isn't merely its raw strength, but also its cutting-edge instruments, including state-of-the-art sensors and spectrographs. These apparatuses do much more than merely observe; they can dissect and filter the unprecedented light emitted, transmitted, or bounced off massive objects to decode their atmospheric conditions, composition, density, and even mass. Acting as cosmic detectives, they can determine if a planet harbors water, organic compounds, or even oxygen. The James Webb Telescope can answer these questions, elevating it from a passive observer to an analytical virtuoso. It's not just a milestone beyond its predecessor. Hubble, it represents a quantum leap. If Hubble's revelations left you awestruck, prepare for a bona fide spectacle of radiant. As we extend our gaze across the intricate tapestry of the cosmos, it's vital to concentrate on one specific spotlight in the celestial concert, Proxima B. Since its identification in 2016, this intriguing planet has emerged as a Shakespearean epic filled with intricate structure and conundrums, captivating astronomers and astrophysicists alike. One might wonder about its allure. First, Proxima B dwells within our cosmic neighborhood, just 4.2 light-years from Earth. To illustrate, if you could defy the universal speed limit and travel at light speed, you'd arrive in just over 4 years, roughly the time it takes your favorite TV series to finish its final season. But delve deeper into why this proximity holds such importance. We're exploring a cosmos stretching across more than 93 billion light-years in diameter. Thus, discovering a planet so nearby and thus accessible for scientific inquiry is like uncovering a gem in a mountain-sized haystack, a gem that might harbor secrets about life itself. In the grand embroidery of the universe, Proxima B is an intricate thread offering clues that could revolutionize our understanding of habitability and life beyond Earth. It's not solely Proxima B's proximity that excites researchers, but also the enthralling indications that it isn't merely Earth-like but potentially Earth 2.0. Proxima B orbits serenely within its star's habitable zone, where conditions are neither too scorching nor too frigid, but ideal for liquid water. Envision waterfalls, wandering streams, expansive lakes, and perhaps oceans as deep and mysterious as the Mariana Trench. However, before we dream of voyaging to Proxima B, we must ponder a few of its traits. For instance, a single day on this fascinating exoplanet spans roughly 11 Earth days. Picture dawns that slowly usher in daylight, followed by afternoons and sunsets that linger, providing dazzling hours photographers would covet. Though idyllic, This has profound consequences for climate and habitability. How would human circadian rhythms adapt to Proxima B's cycles of light and dark? The fundamental rhythms of life as we know them would be both enticingly familiar and bewilderingly strange. It's as if nature hands us a puzzle within a puzzle, testing our criteria for what makes a world livable. The James Webb Telescope delivers its capabilities like a colossal Swiss Army knife. It's more than merely a telescope, it's an exceptional research facility in the void of space. Thanks to its creative design, astronomers don't simply observe planets, they scrutinize them with instruments that rival top-tier laboratories. Employing advanced spectrographs, Webb can analyze the light stemming from and reflecting off these remote planets. Each element or compound in an atmosphere absorbs or emits light at distinct wavelengths. By interpreting these signatures, scientists can perform remote biopsies of these celestial objects, deducing their atmospheric pressure, density, and even the presence of key life-supporting molecules like water, organic carbon compounds, and oxygen. Space science isn't only cosmology, it's space forensics. We don't passively await clues. We actively hunt them, examining molecules and atoms that form these mysterious worlds. Webb isn't just an eye in the skies. It's a highly specialized lab, specialist, and data analyst all rolled into one. Its instruments enable us to convert theories about alien worlds into testable hypotheses, reshaping our understanding of possible life-bearing planets beyond our blue dot. Astronomers using the James Webb Telescope detected something unexpected from Proxima B, a signal so extraordinary it reverberated through academic halls and social media. Dubbed a potential technosignature, it was an electromagnetic transmission so puzzlingly structured it might signal the presence of an advanced civilization. But as swiftly as it emerged, the signal vanished. No repeats, leaving behind not only profound silence, but also a labyrinth of open-ended questions and rampant hypotheses. Now, Harvard researchers are spearheading a novel dimension in the hunt for extraterrestrial intelligence. They plan to repurpose the James Webb Telescope into a kind of colossal night vision instrument. To detect artificial illumination city-like glows on distant worlds, both on their dark sides and their lit hemispheres. We're talking about the possibility of detecting luminous networks akin to metropolitan landscape cities pulsing with civilization, their radiance spilling over planetary oceans. As we continue to unravel the universe's mysteries, the quest for extraterrestrial life expands beyond Proxima B. Our extraordinary expedition penetrates deeper cosmic territories, fueled by technological marvels and profound inquisitiveness about our place in existence. The future of exoplanet exploration. Ongoing breakthroughs in cosmology and space exploration have led to the discovery of numerous exoplanets with potential habitability. Tools like the James Webb Telescope, biosignature analysis, and Earth-based observatories have enhanced our capacity to spot and scrutinize these far-off worlds. A particularly captivating niche involves the hunt for exoplanets positioned within their stars' habitable zones, the Goldilocks regions where liquid water may persist. The farther we venture, the greater our reach becomes. Like master detectives, we survey the boundaries of the unknown cosmos, primed for revelations that may challenge our perceptions of life. A sense of marvel endures, a continual thrill that the universe may conceal even more miraculous wonders, awaiting human discovery. The exploration of space stands as one of humanity's most monumental intellectual pursuits. Fueled by curiosity, we journey further than ever before. As we gaze deeper into the cosmic abyss with instruments such as the James Webb Telescope, our comprehension of the cosmos evolves swiftly, as does the prospect of unearthing other forms of life. One of the most enthralling facets of exoplanetary science is the realization that we're not just finding new worlds, we're rewriting the definition of habitability. As we peer beyond our world, we begin to ask, must life rely on conditions identical to Earth's, or could it flourish in environments that are radically different? In recent times, the discovery of extremophiles on Earth, organisms thriving in scorching hot springs or near deep-sea vents, has revolutionized our conceptions of life's adaptability. These hardy organisms demonstrate that life might exist in places once deemed uninhabitable. The prospect of finding life beyond Earth now seems more credible than ever. Moreover, progress in artificial intelligence and machine learning is dramatically improving our capacity to analyze the vast datasets collected from distant planets, spotting patterns humans might overlook.